Hello, today we are going to explore logarithmic differentiation. In this technique, we take the natural log of both sides and then we differentiate implicitly. So we're going to first recall some of our log properties. So we know that if you have two variables multiplied together inside the argument, we can go ahead and just break them apart as the sum of two logs. Similarly, if it's division of the argument, then we can just subtract the two logs. And our power rule, if I have ln of a to the x, I can move the x out in front and multiply it by ln of a. All right, we're going to use those properties in several different cases. All right, so let's go ahead and get started. To do a derivative like this, extremely difficult. But as soon as we do logarithmic differentiation, it becomes relatively easy. So when you're looking at this, first thing you should do is the algebra. Let's take the log of both sides. If I take the log of both sides, that means this side is ln of y, and this side I now get to use that property I just talked about, where I get to drag the 6x to the fourth in front and multiply it by ln of 5x squared. All right, now we do exactly what we did in the past 2 days with 3-7 as far as implicit differentiation. We take the derivative of ln of y, which is 1 over y dy dx. And then you take the derivative of this side, keeping in mind that's a times sign, so you're going to have to use the product rule. So you do one function, 6x to the fourth, times the derivative of the other function, which is 1 over 5x squared. Make sure you don't forget the chain rule, times 10x. You could write dx here, but I'm going to skip that step. Then I add on ln of 5x squared times the derivative of 6x to the fourth, which is 24x cubed. Please be careful that you're putting parentheses around the 5x squared, because if you don't, we're unclear as if it's ln of 5 or times x squared. You need to make sure your argument is in parentheses. All right, now we just need to go ahead and solve for y prime. There's only one y prime over here, so I just go ahead and multiply both sides by y. I'm going to rewrite this a little bit because I know if I have x squared here on bottom, that's going to take 2 of these guys out. So I have 6x squared over 5, or 6 fifths x squared. And then I have the 10x. So I'm going to go ahead and reduce the 5 as well. And so the 5 is going to go in here twice. I'm going to put the x's together, so I have x squared and x, which is x cubed. I have 6 times 2, which is 12. So that part just becomes 12x cubed. And then over here, not much simplifying that can be done, so we write 24x cubed ln of 5x squared. And then we go ahead and just replace the y with what the y actually equals. So the y in our original problem was equal to, it's kind of hard to see since I wrote on it, but 5x squared all to the 6x to the fourth. So I'm just going to replace this y with that expression. So that's going to be 5x squared, 6x to the fourth, and then I'm going to write exactly that whole thing down. So 12x cubed plus 24x cubed ln of 5x squared. And then I'm just going to go ahead and leave it. That is y prime. All right, let's look at another one. Same mentality. We want to get that exponent down, so we just take ln of both sides and differentiate implicitly. So first thing I'm going to do is rewrite it though. Ln of y equals 3x squared times ln of x. And now I take the derivative. So ln of y becomes 1 over y, y prime or dy dx, however you're writing it. This side becomes 6x times ln of x plus 3x squared ln of x. Make sure you're using the product rule, so you take the derivative of one function times the other, plus the second function or first function times the derivative of ln of x, which I messed up one, sorry, 1 over x. All right, and then I simplify that a little bit. Basically, all I can do is take that x out and multiply both sides by y. Again, please make sure you're using parentheses. 6x ln of x plus 3x. And then we replace y with what it initially was, which is all of that jazz, x3 to the x squared. 3x squared. And then I have 6x times ln of x plus 3x, and we're done. All right, if you think you got the hang of this, why don't you go ahead and try this one without my assistance. Stop your video, give it a shot, and then come back and check to make sure you got it right. All right, again, first thing I'm going to do, take ln of both sides, rewrite it, and now take the derivative. So I have 1 over y prime, the derivative of tangent, secant squared. Again, I'm using the product rule. All right, lots of practice with the product rule. Secant squared times the second function, and then flip it around so you have tan x times 1 over x. And then go ahead and solve for y. Again, this order, right, over here doesn't matter which one you're doing first, that kind of thing. You can flip-flop it, stay consistent, whichever you prefer. Again, you got to make sure you're using parentheses. Not really any sort of simplifying that I can do over here, so I'm just going to write it as is. And then I'm going to replace y with what it initially was. Do not put ln because it was not initially ln. Initially it was just x to the tangent of x. So x tan of x times all this stuff, and we're done. All right, so that process is nice because otherwise we wouldn't be able to take the derivative of functions raised to functions. Okay, but we also use it when maybe the derivative using all the rules we know so far are really nasty. So let's look at this second one, or this last one here. So I have a derivative. I've got quotient rule, I've got product rule, I've got chain rule, lots of icky stuff. And if you want to go through, and I might encourage you to do so just to practice your skills, go through and see what you get and see if you come up to something like we're going to get with our logarithmic differentiation method. So the reason why it's nice is we take ln, all this stuff, and then we use all our properties that we have. So one property is if you're multiplying, right, because this is ln of all of this jazz, you go ahead and just break that up. So it's 2x plus 1 quantity squared plus ln of x squared minus 2 cubed, and then divided by, so since it's divided by, we subtract ln of e to the 5x. Okay, then I can use the power rule and pull down these 2's and this 3. And, well, technically I could pull down that 5x. So I have 2 ln of 2x plus 1 here. I have 3 ln of x squared minus 2. And I have 5x ln of e. And don't forget this side, which is ln of y, because you have to work with both sides. Now, some of you could have seen right here, ln of e to the 5x is just 5x. Some of you take the power rule, see, okay, it's 5x times ln of e. either way, ln of e is going to cancel each other out, so ln of e is just 1. So this becomes our function that now we go ahead and take the derivative of. So I've got 1 over y prime. This is just a constant times a function. So remember when we take the derivative of a constant times a function, it's just a constant times the derivative of this function. And the derivative ln of 2x plus 1 is 1 over 2x plus 1. Please don't forget the chain rule. Times the derivative of the argument, which is 2. Same thing over here, 3 over x squared minus 2. And then, or I'll leave that step, 3 times 1 over x squared minus 2. And then the derivative of the inside guy gives me 2x. And now the derivative of negative 5x is just 5. All right, let's just do some little simplification over here. So I'm going to put the 2's together. I'm going to move the y over here, so it's going to be y times all this stuff. So it's going to be 4 over 2x plus 1 plus 6x over x squared minus 2 minus 5. And then all we have to do is plug the y back in, which is all of that stuff. It might take me a while to figure out how to write all that. 2x plus 1 squared times x squared minus 2 cubed divided by e to the 5x times 4 over 2x plus 1 plus 6x over x squared minus 2 minus 5. You could maybe go ahead and get a common denominator over there, but we don't need to. So this derivative is really pretty ugly. With logarithmic differentiation, it's kind of nice because you have that derivative of ln is just 1 over the stuff. And so I kind of like this method better than using product rule, quotient rule, chain rule all in one. All right, I hope this is enough to get you started on your worksheet. Good luck.